Our next presenter is on an interesting topic that's driving so much and fueling the growth of flash memory as we look at in artificial intelligence, machine learning, big data analytic type of and cognitive learning type of applications. We have Stephen E. Luke, who's Vice President, Deep Learning, Global Chief Data Office at IBM, where he leads the development of platform and infrastructure components for machine learning and deep learning in the cognitive enterprise data platforms, IBM's data lake technologies. He also is focused on applying the deep learning in the enterprise to accelerate the use of cognition in internal processes while maintaining governance, security, privacy, and trust. His work has both generated revenue and showcased cognition at IBM scale for clients. Before he joined IBM, Stephen led the design of high-performance computing, the whole HPC space of infrastructure for artificial intelligence, launched the first model parallel distributed training framework for HPC at Samsung Research America. Stephen earned a PhD in computer science from the University of Alberta. He is presented at many events, including IBM Think, IBM CDO Summit, NVIDIA GPU Developer Conference, IEEE, and too many more to mention. Please welcome Stephen E. Luke.
Thank you. Cheers. Then be some very bright lights. So I don't see too many people walking out of the room, so that's a good sign. So first and foremost, I want to do just a quick intro. That was a great intro. You know, I'm humbled to be here, so thank you for that. But I just like to distill things a little bit. I am from a transformation and operations group within IBM. I don't specifically lead a business unit. Some of our technologies and derived technologies have made their way to business units, but it offers a unique perspective. I would say, you know, we have 50,000 plus users on the platform that I'm part of. You know, thousands of data scientists working every day, along with production applications that are fed off the same system. So some of those production applications are feeding dashboards for the CEO and SVPs, in addition to empowering our resellers in terms of, you know, how they target their clients. Okay, so that perspective is slightly unique. In addition to, we host 2 CDO summits, or actually, I think it's up to 4 now per year. 2 in North America, Japan, Dubai, and a few more, I think. And from there, we have close to 600 C-suite from very large firms across the world. And we have steered them in their cognitive transformation. And I bring to you some of those insights and some of those perspectives from those meetings. So what I'm not going to do during this presentation is I'm not going to coach you about doing data augmentation in memory, data augmentation in Flash. What I'm going to talk to you about is how Flash has enabled production use cases, hundreds of thousands of experiments on our platform for deep learning, in addition to how it enables our high-performance compute infrastructure on a hybrid multi-cloud scenario for IBM's transformation. Okay, so let's kick it off. So this intro slide is an interesting one. So really, there is no AI without IA. So IA being information architecture. Okay, so if we revert back to the 1980s, you know, deep learning was something that was being explored. Why did it not, you know, transform the 80s like it has done since 2012? The real gist is we didn't have the computational power and we didn't have the data, okay? Now, to launch 250,000 experiments in 18 months, dealing with 60 terabytes of data for each one of those experiments, I can tell you that it was crazy expensive in terms of the storage, the monetary cost, but also in terms of, you know, providing a tiered level of access for those experiments along with the production application, okay? So another thing to consider is that 80% of data is inaccessible, untrusted, and unanalyzed. Now that's a big deal because governance is a really big deal with data. It's actually, that's one of the other insights I hope to bring to you. The governance of data is changing the way that we use data for AI. We cannot assume, like the open source does or academia does, where we have these glorified training assets that can be used and preserved. We have to use source data much more often. And that becomes problematic for governance reasons because we have to no longer preserve that data over time. We have to always go back to source data and make sure we disregard storing any cache copies of said data. Very, very challenging. Now, again, another statistic here, 90% of companies are looking at ways to adapt the way that they use data within their organizations. They know that dark data is both a liability for governance and regulatory aspects, but also potentially they're losing the ability to have potential insights for their transformation or potentially to sell that data for monetary reasons. Okay? So this is, if you've ever been to any of the IBM Think conferences or had presentations by Rob Thomas, this is the AI ladder you're about to see. And I can say this resonates very well with myself as a practitioner. I'm considered a practitioner at heart, a technical VP at IBM. And this is the basic journey that we go through for almost every single use case that we have within our system, within our platform. Okay? So there's the collection phase, the organizational phase, the analysis, trust, and the infusion stages. Now, if we look at the collection phases, this is really hard to do, okay? What everybody tries to do and fails with is that they try to adapt their platform to every use case or every co-development project that they have. And that's really, really hard to do. What you need to do is basically provide a performant access in a very limited number of subsets of APIs, so you're able to ingest different types of data. Some being high-frequency data, some being inline data, some being batch data. It really depends on the use case, and you have to let use cases define how that update frequency is for the data. The organizational aspects are really important. If you're dealing with a hybrid multi-cloud scenario right now, so if you're trying to create multiple panes of glass into every single environment, that's non-extensible. It's too expensive, it's too hard to manage. You have to look at single panes of glass so that you have a single view of what your data assets are across the board. So one of the things that we've tried to envision and try to unfold in our organization is a minimal set of services that we can drop within a data silo and have bidirectional governed data flow, including the cataloging of said data, adhering to business metadata, which we're going to talk a little bit later on, to make it accessible and discoverable and governed. Okay. Now, in terms of trust, what people really don't like and how you lose credibility within an organization is if you present results that are frequently changing or you can't justify them. Okay. So you really have to have a single source of the truth. If you're going through, looking at the provenance of a derived data set and you realize that it's similar to another derived data set, but it's not on the provenance trail, then what can happen is you could be utilizing training data ineffectively. You're having duplication of training data, non-uniform access to training data, which means that you're oversampling certain parts of that data. In addition to when you're doing aggregation, collecting statistics, presenting results, that can provide incorrect results to potentially a business leader or a business unit. So you have to be very careful about that. Now, the infusion, this is where we like to list and provide derived data assets. But how do you justify what a derived data asset is? Within the organization, what we try to do is we try to look at those data assets that benefit other projects or projects that have similar requests so that we're not duplicating the work, right? We have hundreds of petabytes of flash storage powering our data platform right now, in addition to petabytes of onboard storage on our high-performance computing nodes. Those that know the Power 8 system was one of the first systems, if not the first, to employ PCI Gen 4 within that system. So we're adhering to this. We're still using flash on those systems with the very high-speed interconnect. So providing all those high-performance storage is really what's enabling us, because here in this whole prong ladder approach, we're providing 250,000 experiments for very large sums of data in the order of 60 terabytes for each one of those experiments for this specific use case I'm speaking about, in addition to over 19 production applications that are feeding various units throughout the organization. And what people really don't like is when we see a degradation of service in a production application just because a data scientist launches a workload. So how do we do that? That is the flash storage, the tiered approach to the flash storage in the back end. Okay, so the data management, this is some of the challenges that we frequently see within our organization. The ingestion and preparation cycles are too time-consuming. 2.5 years ago, I met with one of the SVPs, and I said the biggest problem in data science is that the ideation to product phase is too elongated. We spend 80% of our time getting access to data, preparing data, normalizing data. This is in such an extreme right now that within all of my teams, I have a 1-to-6 ratio of data engineers to data scientists. It's problematic. We need to make this easier for data scientists to have access to data, normalized data, deduplicated data you're going to see on some of the later problems here that I talk about. Silos of infrastructure. I talked to you a little bit, alluded to the fact of having minimal sets of services to provide bidirectional data flow, governed, curated, quality, secure. Those minimal sets of APIs, those minimal sets of services that need to launch, I suggest containerizing them, making it simple so that they can be reused and deployed at will in each one of the data silos. Federated learning, distributed federated learning is something that we'll talk a little bit about later too. I'd like to also just take a little bit of time right now to talk about how 95% of the use cases that enterprises are facing right now are not the use cases that you see talked about from Facebook, from academia, from Google, from Amazon. 95%, that's a huge portion of this pie, is use cases that there is no prior art to. It's very unique for a specific organization. There's a lot of stuff in speech. I used to be in speech recognition. I sponsored Andrew Ng's lab in 2013. I worked heavily with Berkeley. Everything under the sun with image recognition, I did. Third place in ImageNet in 2016. Those are really great use cases, and there's a lot of stuff happening in autonomous vehicles, et cetera. But that other portion of the pie, the bigger portion of the pie, there's no solutions. We don't know what to do. So that's something to consider. Consider what you're targeting. If you're doing a lot of data augmentation, close or within memory or within chip, that's a really interesting scenario, but I can tell you from a practitioner's standpoint, an NLP, dealing with discrete values versus continuous values, as an example, continuous values are very easy for data augmentation. Okay, you get minor improvements in accuracy, great. We can argue that if you want to. I'm going to stay for 30 minutes thereafter. But in the discrete world, which is the world that I typically deal with, is a much harder scenario. That's like saying that Sarah is equal to Sally. And that's fundamentally different within my systems. I'm linking data, I'm trying to understand frequency distribution, I'm trying to understand the linkages of different data sets, and changing those discrete values basically breaks everything, or I just overfit like crazy, okay? So those data augmentation tricks that people talk about, not so useful. We do a lot of generators within our organization, looking how to generate similar data to the data that we've seen, and we're going to talk about that soon. But data augmentation in the continuous world, very hard in my enterprise use cases. Talked a little bit about that one. This one's an interesting, analytics on stale data. I would say 20% of the use cases that we're seeing is around potentially problems where stale data leads to incorrect results. The model hasn't adjusted for changes in potential fraud or fraud threats. So that's a big issue on mainframes. That's an interesting issue for myself. Those types of questions are open research questions. So you got to make sure that the frequency updates for your data is very well understood for the use case that you're dealing with. And then, the provenance of data, understanding where the data comes from, the deduplication of data, all those aspects are really important. Flash is really expensive, and what the CFO really doesn't like is when I say, hey, I want $20 million more of Flash, or I want $40 million more of Flash. A lot of what we've found is there's an incredible amount of duplication throughout the organization. There's derived assets. There's just too much, and we have to look at ways that we can make it simpler to understand when something is a duplicate of something else or very similar to something else. Okay, so that's another open area that's very challenging for us. And then this one, I mentioned it earlier too, the centralization of governance, global accessibility, and collaboration is really essential. You have a lot of different personas at different skill sets. In addition to, that's for the collaborative aspect. You want to be able to share models when you can, very, very easily. Now, the governance aspect, if you don't centralize governance, you'll never agree upon what your business terms are within an organization. You'll never agree upon what should be governed and what's not governed, or where, in what region it should be governed because of a specific regulation. So centralizing that in the very early stages is one of your foundation stones. You need to make sure that you have that. So this is taking back, we talked a little bit about every one of these. This is how I typically do slides, is they're just precursors to conversations that we'll have. So this is the ingestion phase. I talked a little bit about we're dealing with a lot of different use cases throughout the organization. We have to standardize on a subset of APIs so that we can ingest more performantly. If we try to be able to satisfy everything underneath the sun, then what we have is, basic support, but not really good performance, okay? And certain things work really well in terms of high frequency updates, and some things don't work very well in terms of, batched updates or full ingestions of entire data sets, which need to be replaced potentially on a daily basis, a weekly basis, or a monthly basis. Now, on the later stages, you can imagine some of the things that we do with this data. Often, like I have 750,000 computers that I run through and I collect statistics on to try to understand the behaviors of computers that are potentially going to go down. Okay, now that's 400 million records per day that we're ingesting on the sensor data. That's a lot of data that's just one use case, right? So you take the aggregate of all these different use cases and it gets to be problematic. So you look for those normative types of normalization techniques or augmentation techniques, things like Spark. We're running it through, make sure that it's extensible and dynamic. Really, really important. I think that's about it for the ingestion. My main point here is just to keep it simple. If you try to do everything under the sun, it's going to be really, really hard. This is a fun one for us. As you can see on, it's this slide here. We're going to talk a little bit about a really unique use case within my umbrella. But the basic thing is we have 500 or so data scientists at any given point on the platform, okay? Now, in terms of active experiments, these can be experiments that are running for a couple minutes or an hour or days. We have on the orders of 150 to 200 actively running at any given time. In addition to that, we have about 50,000 users at Q2 of this year. And at the end of the year, significantly more. So this platform is, supporting a large number of users. And how are we doing that? Obviously, we're not doing it in a single location. We're doing it in a hybrid multi-cloud approach. Some of these locations are powered by Flash. Let the use case define when Flash storage is justified, okay? Now, the other thing that's really challenging with running 200,000 experiments is I didn't leave the data, I just said terabytes of data. The realistic answer to this is actually those 200,000 experiments, depending on the data set that we're using, 30 to 60 terabytes of data. So if you can imagine production workloads running off of Flash, now I'm trying to feed data scientist workloads going to high performance computing centers with that amount of source data. This becomes really, really challenging. Now, a lot of people would tend to argue that, well, you're supposed to preserve the data set on the worker node, and then once you're done with that in a multi-tenant system, you evict it, you ingest the new data, and then you start working. So that's really, really great, but you're going to see shortly in a few slides that in terms of governance and regulatory aspects, dealing with open source data is much easier. When you're dealing with enterprise data and potential PI data, having those derived data assets or those cached copies of data that are resident on a system is very problematic. It requires exceptions, et cetera. And I myself and my groups are moving towards a scenario where we never, ever, ever use cached copies of data. We never preserve training data. We always require the source data for our training. Okay, so you can imagine the stress that's going to, force the source storage to provide the performant access. It's not reasonable right now. We're looking at different ways to do it. There's a paper that we published around something called Hoard, which is caching that data in a more effective manner for a very short amount of time, just so that we're not having so many experiments hitting source storage. Okay. So this is just a little bit of dive into metadata and why metadata is really, really important within an organization. Now, one of the things that was really challenging for us, and basically every customer I've ever talked to, which is close to 600 in my 2.5 years at IBM, is metadata and regulatory is a requirement for their organization. So they're looking at ways to provide umbrella terms or understanding of the data that they have within their organization. We had close to 100 people working on this task, subject matter experts trying to label data, trying to agree upon terms, et cetera. Now, I wouldn't say each organization, but I say depending on their level of sophistication, a great deal of those organizations are struggling with this. I know a certain organization that just hired 150 people because they need to show regulatory bodies that they're moving towards governed data. Okay, so this topic, I hope it resonated. I hope you understand why it's important. Now I'm going to tell you a little bit about what it is. It's just basically providing business terms to the data assets that you have, whether that be structured data or it be unstructured data. So you can imagine maybe it's a contract on the unstructured world. Maybe then you dive into the specific details of the contract, what the PI data is in there, the terms and conditions, the obligations, the SLAs within that contract. On the structured side, this might be account information, this might be email addresses, employee IDs, seller, reseller details, et cetera. So within IBM, we have in the orders of probably 5,000 or so business terms. And what we're trying to do, and what we have done now, is we're able to basically provide a complete level of automation to labeling our data. So you would assume that all data is labeled, but really it's not, especially for companies that have been around for a long time. You don't know, you can't agree depending on the business unit. So when data gets ingested into the platform, it goes through a governance phase before it's consumable by anybody else within the data lake, before it's put on the catalog for consumption. That process used to take sometimes 90 days, and that's incredibly problematic. One, because it's ungoverned data. Two, it's because it's dark data. It could potentially have insights that people can't utilize. Okay, and then you have co-creation projects and SVPs hammering you why a certain project can't move forward, and it's because, hey, we don't know what that data really is. In addition to regulatory aspects, sometimes limit how data in its raw form can move. So this is where we start talking about distributed federated learning. So you're moving weights around instead of the actual physical data. Okay, this is much, much easier for you. And then the other thing that's nice about this scenario is that those centers that don't have enough training data to do things like transfer learning, you're able to give them access to more data. Now, the argument on the flip side is to say, well, for certain types of applications and use cases, the training could take weeks or months or years. Okay, I will argue the contrary to say most of the use cases are offline. I don't have a lot of them that are online real-time type use cases, maybe for inference and so forth, but for the training aspect, it's not such a big deal. If I can tell that company that just hired 150 people to do this labeling over the course of the next 18 months, I can tell them that in 2 weeks I have a model that can give you basic 90% coverage of all your data with top 1 to top 3 recommendations. It's sold, it's done. And I can tell you that is one of the products that I've launched or I am in process of launching in September. So it's a really, really important problem, the governance of data. We talked a little bit about this previously, the training. Luckily, Sumit Gupta, who's the head of power at IBM on the AI side, luckily, he came to visit me at Samsung like 4 years ago. And luckily, I didn't buy anything from them at the time, excuse me. But I told them some of the insights that I had, what I would buy from them. And those things included PCI Gen 4. Likewise, NVLink directly to the CPU. So making sure that you're employing the best hardware behind the scenes is really important. And I can tell you that every one of those high-performance computing nodes, what they have? They have RAID flash, RAID 0 flash on every one of those nodes for performant access to data. And maybe there's certain cloud vendors that state that they can access CAUS and whatever remote storage in a very performant manner. I will show you basically on every single one of those platforms, depending on the use case, you're not getting effective use of that GPU. So you might be spending a lot of money on these GPUs and only utilizing them at 40% because the back-end storage is not effective. And there needs to be more work on this. The open source frameworks don't really address these aspects. There's certain things that they do, but they ultimately assume that it's local storage. They don't do it very well. Okay, so make sure that you're using your GPUs effectively, and things like Flash, which I've been using for many, many years, is one of the advantages, but you have to do it right. There's certain things you want to do right. Okay, all the way doing, potentially RAM disks and things like that. Okay. Now the deployment of AI models. So this is another really challenging one. So depending on the use case, potentially you're running on CPU, potentially you're running on inference GPUs. How do you get the data there? Most of this stuff, imagine mainframes. This is an inline process, right? So providing effective inference models or scoring models within a mainframe with very close access to the data is really, really important. But ultimately, we want to write that data out somewhere as well, right? So all of those aspects, have to be taken into consideration in terms of what you're doing. Now, on the contrary, a lot of the scoring mechanisms, as I mentioned earlier, it doesn't really matter. I can do it offline and give the results, and these feed dashboards, whether that be in terms of proactively understanding when a computer's going down, or potentially giving insight to a risky contract, or potentially telling a reseller or one of our sales advisors that, hey, this client is better to target because they're more probable to buy something. All of these things feed real production, use cases, so it's important. So now what I'm going to talk about here is, we have a wide variety of use cases within IBM around cognition and transformation within our organization. Now, from that, we have things like Client 360. This gives a 360 view of our clients. And what does this enable? It enables a lot of different things. But one of them I talked about already, and it's been talked about before, so I'll share it with you more formally, is understanding those clients and which ones that we should prioritize in the organization. So this takes in hundreds of data sources from within the organization, aggregates them together. In addition to, it takes on a lot of external data, all coming through the same APIs, all being saved on the same flash storage, all being updated at different frequencies. Okay. In addition to operational risk, contractual insights, this is looking into contracts and understanding, the terms and conditions that were beneficial, those that were not. The operational risk one's an interesting one. You can consider we have a network of different suppliers throughout the globe, whether that be people or hardware or resellers, and how natural disasters really impact the company. We have to understand that very, very quickly because we have agreements with companies, and companies are depending on us to provide what we promise to provide. So if there's any sort of breakdown in a specific supply chain, we need to know about it as quickly as possible so that we can adapt and reroute, whether that be hardware, people, et cetera. The AI sales enablement, maybe that be, potentially how different products interact more effectively together, how there's potential for a company using XYZ to also use, some other product that is similar, but or similar and works very effectively with XYZ. That's basically where the AI sales enablement comes from. Now, on the right, you see one of the key differentiators on our platform now, and it had failed in years previous, is that you have to make it easy for co-creation projects. Okay, this is really, really essential. You need to make it easy for people to get on the platform. If it's not easy for them to get on, they're not going to want to be on it. They're not going to evangelize it. They're going to be opponents of it, et cetera. Make it easy. Data silos, we talked about that. That's problematic. The governance thing is probably the number one foundation stone, whether that be on the cloud, whether that be on-prem, et cetera. Really, really important. And then that minimal set of services that you can deploy and utilize, also really, really important, because there's going to be restrictions on how data can flow. And if you're expecting people to do that work for you, it's not going to happen. But if you have a bunch of services that you can drop in and then start extracting that data, caching that data, it makes it easier. And then this is, not purposely a sales pitch at all, but this is some of the products that we're using behind the scenes. Spectrum Scale on the bottom. This is our flash storage. It's dynamic. The nice thing about it is if we're hitting performance issues, I can throw in another InfiniBand card. I can, populate more disks. Along with Spectrum Discover, understanding the data within that system, Cloud Object Store, up to, I think it's 700 megabytes per second of transfer there. Really, really important. For certain types of use cases on the cloud. Now, this is just my final kind of be-all, end-all slide here. So data quality, huge issue. Every single project we touch is problematic with the data. I promise you, whether we need to in-paint data, understand the data, get rid of false data that is incorrectly labeled, it's a huge issue. I say we spend most of our time in those spaces. Limited amounts of training data. It's not like the open source world. It's always scrunging together different amounts of training data from different locations. That's where the distributed federated learning is really important. Remember, the distributed federated learning is important, but that minimal set of services, that's how we enable that to extract that data in that federated way. The co-location, I talked about that. This one, if you could listen to one thing during this talk, this is it. Continuous learning, not the formal definition of continuous learning. This is adapting models automatically to new data and changes in business requirements. This is one thing that business leaders are terrible at, is dictating to the data scientist what the KPI is, what the metric needs to be. So continuous learning, we are building that, adapting it internally so that we're able to minimize our technical debt for machine learning projects. So the portfolio that I have is 200, right? And we're moving through that portfolio very slowly, but I can tell you that I can't designate 5 engineers for maintenance of technical debt for each one of those projects. I need to minimize that. It decreases potential, or this is the gist of why I can't store the training data, is I have to use source data, is it decreases the potential governance risk by not storing any more training data anymore. If I always go to source data and it's governed, I have no governance concerns. I have no exceptions that I need to sign off on. And the most important one at the bottom that I just mentioned is the technical debt aspects. So I hope that was interesting for you. I know it's a slightly different aspect of it, but I can tell you that flash storage has really been an enabler for us. We rolled it out internally about 17 months ago, and we're continuously, we just rolled out another 50 terabytes. It's growing as we need to grow, and that's really, really important. You have to consider the cost of ownership and how easy it is to roll out new infrastructure and how easy it is to manage that infrastructure behind the scenes. I'm going to stick around for about half an hour after the talk outside here, so if you have any questions, you're welcome to ping me. But first and foremost, thanks to the family, the Global Chief Data Office at IBM, and that's my contact info. So thank you. Cheers.
Thank you, Stephen. Very